Welcome back to The Lost Tactician. You think modern concrete is tough? Well, prepare to be amazed. Scattered across the European landscape, from the windswept beaches of Normandy to the dense forests of Poland, stand silent sentinels from humanity's darkest chapter. These Nazi-era bunkers, subjected to devastating bombardment, corrosive salt spray, decades of freeze-thaw cycles, and even deliberate demolition attempts, just refuse to crumble. While contemporary buildings erected just decades ago show their age, these structures from the 1940s remain defiantly intact, their thick walls bearing scars but never yielding. Today, we're not here to glorify a regime, but to unravel an engineering mystery that continues to confound modern civil engineers. How did these fortifications achieve a level of durability that seems to mock the passage of time itself? Echoes of fortitude, the indestructible paradox. Stand before the colossal Epelec bunker in northern France, a structure so massive that Allied forces dropped 12,000-pound tallboy bombs directly onto it, and you'll witness something extraordinary. The concrete roof, cratered and scarred, absorbed impacts that would have obliterated any conventional building. Walk the Atlantic Wall defences along the French coast, where German engineers poured over 17 million cubic metres of concrete between 1942 and 1944, and you'll find structures that have withstood 80 years of relentless ocean spray without significant deterioration. The question isn't simply why they survive, but how they were engineered to endure conditions that would reduce modern construction to rubble within generations. This is a story of obsessive over-engineering, wartime desperation transformed into architectural permanence, and methodologies so extreme they bordered on madness. The secret to these bunkers' longevity lies not in some mythical super-concrete or lost Nazi formula, but in something simultaneously simpler and more extraordinary: absolute, uncompromising excess. German military engineers operating under the standardized Regelbau system designed fortifications with a singular philosophy that modern cost-benefit analysis would immediately reject. Every bunker was a monument to paranoid perfectionism. Standard permanent constructions, classified as Baustärke B, featured reinforced concrete walls measuring at least 2 meters thick. The most critical command structures, designated Baustärke A, boasted walls exceeding 3.5 meters in thickness. To put this in perspective, imagine constructing a residential building where every wall matches the thickness of a modern highway overpass. The sheer physical mass created structures capable of absorbing and deflecting the kinetic energy from 1,000-kilogram aerial bombs and the heaviest artillery bombardments the Allies could muster. But thickness alone doesn't explain their resilience. These weren't simple concrete blocks. German engineers employed construction methodologies that, transformed raw materials into virtually monolithic fortresses. The concrete was cast as single, continuous structures rather than assembled from prefabricated components, eliminating the weak joints and seams that plague modern construction. This monolithic approach prevented delamination, the process where layers separate under stress, which accelerates structural failure. Within this massive concrete matrix, steel reinforcement bars were embedded with a density that far exceeded civilian construction standards of any era. The rebar wasn't merely structural support. It created a three-dimensional skeleton that distributed stress across the entire structure, preventing the catastrophic cracking that occurs when concrete's inherent weakness under tension is exploited by explosive force. The science of survival, materials and methods. The concrete itself was standard Portland cement-based material, identical in basic composition to what Allied forces used in their own fortifications. There was no secret ingredient, no revolutionary chemical additive lost to history. What separated German bunkers from their contemporaries was how the material was deployed. Engineers specified lower water-to-cement ratios than typical construction practices, creating denser concrete with fewer internal voids where moisture could penetrate and cause freeze-thaw damage. The aggregate materials, carefully selected local stone and gravel, were mixed with obsessive attention to gradation, ensuring maximum particle packing density. Every cubic meter of concrete represented not innovation in materials science, but perfection in execution of known principles. Some of the most critical structures incorporated even more sophisticated defensive architecture. At Hitler's Wolf's Lair headquarters in East Prussia, engineers constructed bunkers with double wall systems, separated by gaps filled with basalt grit or crushed stone. When bombs struck, the outer reinforced concrete shell absorbed the initial impact while the granular fill dissipated shockwaves before they could reach the inner protective layer. This principle, similar to modern spaced armor used on tanks, transformed the bunkers into shock-absorbing behemoths. Strategic placement amplified these defenses further. Bunkers were frequently buried underground or integrated into natural terrain features like cliffsides, using the earth itself as additional shielding. Curved wall designs, rather than right angles, deflected blast waves and projectiles at oblique angles, reducing the effective force transmitted to the structure. The Atlantic Wall alone consumed resources on a scale almost incomprehensible by modern standards. Over 500,000 workers labored to pour those 17 million cubic meters of concrete, using steel tonnage that could have built hundreds of warships. This wasn't efficient construction, it was brute force engineering backed by an industrial economy operating under total war conditions. Modern infrastructure projects, constrained by budgets and timelines, simply cannot justify such extravagant material investment. A contemporary highway overpass might use high-performance concrete with superior compressive strength, but it achieves economy through precise engineering that uses only what's necessary. Nazi bunkers used everything available, then doubled it for good measure. Today's civil engineers studying these structures discover uncomfortable truths about modern construction philosophy. We've optimized for speed, cost, and initial performance, often sacrificing long-term durability. These bunkers, built under wartime urgency with what we'd consider primitive materials, will likely outlast virtually every structure we're building today. They stand as accidental monuments to what becomes possible when durability becomes the sole design criterion, when budget constraints evaporate in the crucible of existential conflict. These bunkers weren't built for posterity or architectural achievement. They were instruments of war, components of an apparatus designed for conquest and oppression. Many were constructed using slave labor under horrific conditions. Their survival is a testament to engineering principles, not the ideology that demanded their creation. As you explore their remains today, often repurposed as museums or slowly being reclaimed by nature, remember that the same qualities that made them indestructible, the obsessive attention to detail, the massive resource commitment, the refusal to accept limitations, were characteristics of a regime that applied similar extremism to unspeakable ends. Yet there's value in understanding what our predecessors achieved, even when separated from darker purposes. These structures teach us that we possess the knowledge to build for centuries, not decades. The question isn't whether we can create lasting infrastructure, but whether we're willing to make the commitments necessary to do so. In an era of planned obsolescence and quarterly profit reports, perhaps that's the real lesson these silent concrete giants offer. True permanence requires resources and dedication that transcend immediate concerns.
If you found this exploration of history's enduring monuments compelling, hit that like button and subscribe to The Lost Tactician. We're diving deep into the intersection of engineering, survival, and the lessons written in concrete and steel across history's battlefields. Share this with anyone fascinated by how human ingenuity, for better or worse, leaves marks that time itself struggles to erase.